The problem is essentially one of routing electricity through the electric grid. Right? This is a nonlinear problem, and there are many different pathways that the electricity can potentially take depending on how you set the voltages at the different buses in the network. An appropriate setting of these buses, of these voltages at these buses, can lead to low losses in the system, and that is desirable because you're wasting very little energy in reaching the demand points that you want. And that's the essential goal. The goal is to find those points of operation where you have minimal losses, and as a consequence, you're wasting very little energy. This is all on the algorithmic side. So this is just on the operation of a given grid, and whatever we have developed applies equally to the current grid as well as the grid of the future. And what we have essentially developed is an algorithm for finding those minimal loss operating points at this current given infrastructure. So what I'm showing you over here is a small network consisting of what I call as a generator that's potentially like your grid, and a couple of homes which are fitted with solar panels. And for example, this particular home has very little solar energy and has a lot of load, whereas this particular home has extra solar energy that it can supply. And in what we are showing is a potential scenario where one home supplies energy to satisfy the demand of the other home, and we satisfy the rest of the demand by actually taking it from the grid. So this is actually a desirable scenario where we are utilizing the energy that we have and actually having minimal losses in the system, as opposed to operating at a point such as this one, where the electricity is routed through a longer set of lines, and as a consequence, you have more losses on this system. And what we try to do is to avoid finding such solutions, and essentially want to find solutions that have the minimal losses in the system. And the algorithm essentially proceeds by computing the region of the search space where you find the lowest possible, and quickly figuring out and subdividing the region and eliminating large spaces where good solutions do not exist. And to be able to do this in a provable fashion is what the research is all about. This essentially is a representation of the search that the algorithm has performed. So essentially, we start with given the initial function, and at that point, we find a solution. And once we found that solution, we basically construct an under approximation. And then we see a gap between what we have found and the under approximation, subdivide the region, and this represents two nodes in the search tree. And then we explore one of these nodes. We again find a gap. We explore the other one, and we find this better solution compared to this one. And at this point, we basically can eliminate a large portion of this subregion because the lower bounds in those regions are actually poorer than the best solution that we have found. The current technology uses more simplified versions of the electric flow model. This actually uses the real physical nonlinear models, and that's not something that's in use currently, largely because the technology to solve these models is not mature enough. And with this kind of research, where we can actually guarantee both feasible solutions and provide levels of approximation of how far they are from the best solution that you can get, we hope that we can actually get this to the mature level that they can be deployed into control systems in short time. The main point is to kind of minimize losses. So if you're minimizing the energy that is being lost as you transmit it through the grid, then as a consequence, you're also minimizing the generated power that you want to consume. Right? As a consequence, you are minimizing the energy consumption, or rather the energy generation that you have. Consumption is more on the demand side. That's something that society at large has got to kind of limit its consumption. This is just meeting whatever society demands as its electric power.